The almost 75% done. And the question for you today is, what have you gained? What is it that you've gained by just waking up? Has it been just waking up, waking up, waking up? Has it been just watching? Or have you been able to accomplish something? Have you been, if someone came to you um, today and asked you, show me, don't tell me what you are doing. I want you to show me what you've been doing for the last 30 days. Okay, we are on 23rd day. For the last 23 days, what will you show? What will you show? That is always the question. If you can be able to answer that question in everything you do, then there is result and not motion. Remember, that is what we discussed, I think, on day 10 of when we were reading the Atomic Habits. Most people are in motion and you feel like you're moving. It's like you are on I've forgotten the name of this machine, on a treadmill. When you are in a treadmill, you're running and you feel like you're moving, but you're not. You're just in the same position. You're not in the same position. You are not moving. You are just in motion. You're in motion. There is no actual steps. If someone told you, show me the distance that you covered yesterday when you were running on a treadmill, you'll never show them. You'll never tell them I came from this point and got to this point. You never. You're on the same position. And this is where most young professionals spend their whole lifetime. You spend being in motion, planning, I'll do so and so, I'll do, I'll learn, you learn the course, you do this. But even after doing the courses, you have nothing to show. So this is always a very, very important question that you should ask yourself. What do I have to show for my hard work? What do I have to show for my early mornings? What do I have to show? I always ask myself this question every day. Before I close the day, I'm like, if someone came to me today, what will I show them? Is the thing that I did. Tangible results. Tangible results. This is at the core of personal development, personal growth, career development, professional development, whatever you want to call it. Growth should be tangible, should be seen. The moment you find yourself explaining things, it means you have not done anything. So that is the question, guys. You've been here the whole time. What can you be able to show? Let me show you someone who has shown, who has something to show. But just before that, we go back to our accountability one more time. Make sure you're checking in. It's very, very, very important to hold yourself accountable. So how many hours did you rock in yesterday? For me, yesterday, I didn't get to my target. I got to 6.5 hours. Let me just confirm. Yeah, I didn't get to my 7, so I got 6.5 hours, which is also fine. But then I could not do the 30 minutes. I couldn't force it. Therefore, I want to know, how many hours did you put in yesterday? Actually, from research, for an average professional, actually for you to go above the average professional, you need to be rocking in around 4 hours. 4 hours of intense work, deep work. If you keep putting in 4 hours, like tracking the way we are doing, and you are consciously utilizing that time very well, you will see a lot of improvement in your productivity. and making sure that that time is spent working on the important things that matter to you. I'm telling you for a fact, if that compounds to 6 months, 1 year, my goodness, you'll be amazed. You'll be amazed. And the other bit is combine the G sessions with excellence. What combining G sessions and excellence means is you're not just recording so that you can feel nice and you have a record. It's a recording because you're putting in the job. And you say that now that I'm focusing and I'm taking myself away from distractions, the work that I am doing, I must give it a finishing touch of excellence. Everything you do it so well, like to the best of your ability. You have thought through everything. That is how you push your skills. If you tend to be doing things shallow, shallow, you become shallow and your life becomes shallow and you just become another average person. So I'm looking at how many hours we did put in. I can see Ernest did 2 hours, a lot of movements. That's good. That's the gist of life. You will never always have time and comfort to do all of them. So that's good. But the goal is make sure you record, you track every single day. Innocent 5 hours, that's fantastic. And then 4 hours, that's fantastic. Claire, this is good. You've doubled up from 2 hours to 4 hours. I love that. Congratulations. I think that's really good. That's really good. We need to celebrate you. And you just came in the other week. Patrick, 3.5 hours. Hey, Job, 7 hours. That's very fantastic. Sam, 4 hours. So Sam has everyone, I think everyone who has recorded the hours, he has been able to hit our target for 3 hours. And that's something that I'm proud about you guys. And I hope that you're taking it very intentionally. And I love that. Then again to your app, go back there again, made your bed, woke up at the expectant time, did your prayers or meditation, you're hydrating every day. I mean, like for now, it's super. I don't know. I feel so thirsty every time. So get that. Hygiene, very important. Preparing your coffee. I'm not taking coffee. I'm on a break, so I'm not taking that. And then I'm joining the challenge. After this, I'll be journaling, reading, and then going for my morning workout as I look forward to hitting my 7 hours of focus. So let's get in. We've said that show, don't tell. And this is the time to do exactly that, to show without telling. So this is some work that I received from engineer Sam Munoru, and I want us just to go through it briefly, check for him because he has. We say that when someone has put in the effort, we must be able to acknowledge the effort and most importantly also get to give feedback so that now they can be able to develop themselves and become better and better and better. So I'm going to do away with, okay, let me do away with uh, these points so that now we have a clean working space. So I'm going to isolate objects and say hide selected objects. So I'm going to retain the bus base and all of that. So I want us to go to the section where we are designing this. Uh, and the first thing we're seeing is we're having two lanes at this point, and then we're having the acceleration, the diverging section, and then we are accelerating to be able to make a U-turn at this point. We're having a U-turn of 14. The section is 14.5 meters, of course, including these 3 meters and the 3 meters here. Remember also having the deceleration or the acceleration section here is always dependent on the amount of space you have. and also the volume of traffic that you have at this point. So and now the trade-off is always about this loan design is meant for urban areas where you don't have a lot of space for the sections. And therefore, and also you anticipate that traffic is moving at a slower speed. So sometimes in your design, you may not be able to accommodate the acceleration lane. And therefore, you may not be able to accommodate the acceleration lane at this point. And therefore, you may not be able to design without it. But of course, the acceleration lane will always serve to the safety and also improving the level of service of that specific section. On this other side, we are talking about now the section for large vehicles. Remember now, this section is for the small vehicles, just like we said. And then now we get to do some widening for what the vehicles have. So I can see that the crossover is right here and all the information is done. So what we do, this is a very well done design, but then we put it to the fire so that we see whatever decisions you made. So I'm going to go to the vehicle tracking. And once I do that, I'm going to activate. I saw your email. I don't know which vehicle you considered. Let me check it one more time. Um, I'm seeing WB14, design vehicle is WB14, inner lane to shoulder. Okay. So I'm going to go back to this one. And once I do that, I will hide this. I go to my vehicle tracking. Once I go to that, let me just put this on this other side. So I'm going to vehicle tracking. Let me load the vehicles. Oh, I had done your test before. So let me go to US design vehicles and then statewide Ashtor 2011. And then after that, yours was WB19. I cannot see it. I don't know whether I can be able to see that here. I cannot be able, but mostly you find that you find that the WB40 is always the obvious design vehicle that we get to use. Let me see whether 2011 has the WB19 right here. So you see yours is WB20. Yes, WB20. So let me get to use that. And then proceed. And then I'm going to accept this. So let's put this design to test. So I'm going to have my track right there, and I can be able to proceed. So this track is coming all the way to this point, and then trying to make a turn all the way to this other side. So you can always have it here. Have it at that point. And then now it will start moving all the way now to this other dimension. And then you move, the track now moves out. Remember, when we are doing this test, we said that the inner lane, the inner lane is always, or rather the inner lane to inner lane turning is done for the small vehicles. and then the inner to shoulder, because this section will always be a widening that is done on the shoulder, will always be for the large truck vehicles. It's important to take note of that. It is not every vehicle that will make the inner to shoulder turn. It is only for the large truck vehicles, which of course accounts for the minimum or for the least percentage of traffic that you're going to have on your roadway. In any design that you're going to do, and this is always the case, you need to be in as much as, and I think this is something also that we saw when we were designing the bell mouth sections. In as much as the manual is telling you this is 14, 10 meters, you need to figure out how do I position the 14 meters to in view of the kind of maneuver that I'm going to anticipate. Yeah, this is when we are talking about the geometry. This is why this is called geometric design. You need to think about how do I position it. Yes, it is 14 meters. Yes, it is 6 meters. Yes, the radius is 4. How do I position it in a manner that can be able to accommodate a smooth and comfortable maneuver for the motorist? So looking at this, we can be able to probably get to modify it a little bit to see how this is going to fit. Remember, you can always use this node to move it to check to modify the sections. So for example, let's say I would want to, I think this is the best route I could master from this one. So what I'm going to do, yes, this is a fairly good design, engineer. So you can see the only thing is the geometry, the geometry, where did you position your curves? Mostly these sections will be very wide. And I think we also witnessed this yesterday, and also the geometry of how the curves happen. And as you can see, this one is going to vary according to the design vehicle that you've chosen. So if you choose WB40, it will be different. If you use you use a passenger car, the section is very different. So I'm going to send you with the vehicle tracking check-in, so that now you can be able to modify your geometry accordingly. So you can see with the section that you've provided, it will be very difficult for this vehicle to be able to make a complete turn at this point. And then you will also note that the Ashtor has not specifically given the actual widening of the shoulder. They are not very explicit on the amount of widening that you need to have on the shoulder, because also the geometry that you have here will be able to determine the amount of widening. So for example, you remember like yesterday we were talking about doing a widening of 3, and clearly you can see it cannot be able to accommodate the design vehicle. It's important to know that also this is more of a bit of a sample design that we are working with. In an actual design, you will have the traffic survey will have been done, and you will know the vehicle that you are working with, the dimensions. And then as you're doing your vehicle tracking test, and actually now I think it's a requirement in almost every urban design, in every intersection design, you must be able to do a vehicle tracking to show the path of how the vehicles are going to move through that section before you complete it. I also got to complete the same. I just did what we were working on yesterday. So this is the same track moving all the way the section around the section, and this is the movement that we are making. And just like what we have seen with Sam, we can see that the section, how we thought of widening the section by just having the 3 meters would not necessarily be able to take care of all our needs or to ensure a very smooth maneuver for the vehicle at this point. So we can be able to actually visualize that. So I'm going to select the vehicle tracking. Let me position it well on my screen. so that it's easy for you to see. I hope you can be able to see the screen fully. I'm going to select the vehicle tracking, and then I'm going to animate. And then in the animation, I'm just going to play it. Um, so I want you to look at something. Just look at the start. There is a vehicle here. I don't know whether you can be able to see it. There's a vehicle at the very start. So we wanted to drive through the section. So we just play and we can be able to see how it's going to make a turn. So you can see it's making a very smooth turn and getting out of the section very smoothly. So this is an important part for you to note, at least now that you know the vehicle as can be able to make a turn at this point. It is easy for you now to modify your geometry to accommodate these. Other than now, you just submitting the design and they have already done the setting out and blah, 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 all of that. They have actually done even the base layers. And then that's when they notice that the vehicle cannot be able to make a complete turn through that section. So this is a very good swept path analysis of any design. It's very important for you to make sure that your design at least is functional, can be able to it can be able to work in real site scenario. So today's session is going to be actually a replica of what we already did last time. And I hope that you also get to work on it. These are not the kind of things that you listen and observe and watch. These are not the kind. They are not. They are not, my guys. They are not. These are the kind of things that you must do. You must experiment. You must do them. Take your time, work on them, experiment. I'm actually offering to give you guys, and this is what surprises me. You offer people to give them guidance and feedback. They don't do it. So I want you guys to be different. I want you to work on it, find some time. Out of the G sessions, you can allocate 45 minutes, work on whatever you can within that time, and then you can be able to submit it for review if that resonates with you. So I will repeat almost the same process. Today, I'm not going to do everything for you guys. I will leave it as a task so that you can be able to work on it, so that now tomorrow we can focus on production of this design. Tomorrow is also is on Saturday. I would encourage you people to take time and work on this design. Probably you'll be off from work. You will get some time. You will not get anyone who is training you on these things. I'm telling you for a fact. And therefore, if you don't do it, it will just be going to waste. And I don't want that to happen to us. So we are going to do the same for this other section. And we say the most important thing to consider is which traffic are we taking where? And in this case, we are taking the traffic on the left-hand side, and we want to take it to the right-hand side. And at what point should the traffic be able to make the turn? In this case, we said the distance should be at least 400 meters and maximum around 0.9 meters. And of course, it's dependent on many other factors. It's dependent on many other factors. For example, the economic activity that is happening at this point, what does the government want? There is, of course, influence and all of that. So you find that there is someone who will be able to do it at even 100 meters from the edge of the whatever. But of course, that would therefore lower the capacity of or the level of service of the road. For example, you can see here we have the deceleration lanes, and then you want to have a U-turn just next to it. It means now it's going to obstruct traffic. So in this case, we do 400 meters. That's what we are working with. And we are already at 400 meters. After that, we get to offset these to accommodate for our section. So remember, if the 400 meters is here, so we want to design. And this is also the other question. If you get to your 400, do you get to have your deceleration sections inside or outside? Should they be beyond the 400 or should they be in the 400? That is also the other question. And of course, remember now, this is where the point of the U-turn should be. So this means motorists can be able to start decelerating before the actual U-turn. So we do the offset, and in this case, you remember we have a deceleration section of 50 meters. So we can do 50 inwards. And then after that, we are going to do another 35 for the diverging section. So let me offset, and this one is going to be, offset, and this one is going to be 35. So we are going to do 35 up to that point. And once we do 35, we can now start doing our work of modifying, editing the entire section. So the first thing is we can be able to trim the median and, just get to remove it for now. So I'm going to remove that part of the hatching. As we said, the next thing would be, of course, what is the width of your deceleration sections. So offset again of 3 meters. So this is 3 meters in, and then of course we want to have our curb at 0.2 or 0.3, whichever capstone you have for your case, and that's it. So once that is done, we can be able to trim all of these other elements. Let me see, how do I do that? Yes, I can be able to select all of these and then say trim. So in the trimming, I want to trim the shoulder and trim this one. I also want to trim this and also trim this. So I'm left with the edge of traveled way of the existing roadway. And these other points, what do I need? I do away with this, and I also do away with this point. And I will also do away with these ones because they are not continuing to that edge. So what I do, I want to connect this point, the edge of traveled way, should be able to taper back to where we have our edge of traveled way of the normal carriageway. And therefore, if that's the case, then we should have a protective curb um, that should be at the back of that section. The other bit is sometimes when you do the offset, it doesn't snap directly to this point. And then also, remember, sometimes you don't have the curb all the way to the roadway. But then again, if you hand it, you can be able to join it directly to that point. But of course, the obvious way you find that it needs to taper back to the edge of where you have your acceleration lane. This is also contextual, depending on what is happening on site. The other thing is, therefore, we can be able to break this section. Remember now the road marking. And these lines that you're having here should be going hand in hand with the principles of road marking. So if you're marking this section, it needs to be broken line. And what a broken line means is vehicles can be able to merge or change their lanes from one lane to the other. So we get to break this, go to the modify, and then there is the break. And then we are going to select this point to break our acceleration. The next thing that we need to do is to match properties. So in this case, I don't know whether we prepared one for match properties. Let me look at what we did for these. Yeah, so we are going to use this one as our, so we match properties with this so that also there is uniformity. Then after that, there is match properties for the capstone. So we want the capstone to be uniform throughout the section. This uniformity of the different elements that are representing, or rather the different AutoCAD objects that are representing our design elements, is very, very, very vital for you as you do your design. So that's it. In this other section, we didn't include an acceleration on the other side. So now I want us to factor it in here. The assumption is the traffic is very, very high, and we have sufficient road reserve, or the median is wide to accommodate for our section. Remember also, this is contextual, depending on what is happening on site. There is no one size fit all. Your work is to be able to provide a solution that is going to work on that specific site that you're in. So I'm going to do my offset for the other section. It's basically the same thing that we were doing. It's the same thing. So I'm going to do an offset, and in this case, it's 3 meters. And if I do that, where do I go? Very close to the drain right there. And then I'm going to do another one of 0.3 to make sure that that's where I have my ditch. It is important also to note this is, as I earlier said, this is contextual, and therefore you need to be careful on where do you position your different elements, so that also you don't become you don't give designs that are not workable on site. So what do I need to do? I can be able to clear these elements because I don't need a shoulder here, and I also don't need that. I also don't need the median, so I can be able to do away with it at that point. Yeah, that's good. I have my sections, and that's all. What I need also to do is I should have uh, I should have trimmed this part, trim right there. Should I? Yes. So I have my acceleration section here, and therefore what I need to do, this one will need to taper into the edge of traveled way. Remember, now you're directing your traffic back to the main highway. That is what you're doing at this point, and therefore this should have been continuous up to that area. And then also I need to do away with these lines because I don't need them. Trim that, and then I'll do away with that. And then I'll do another offset of 0.3 meters. And then I'll push it here. Make sure that it tapers nicely into this. I make sure that it tapers nicely into that. And then once that is done, I use MA again to match properties. For this section, this is the deceleration. And then also for the capstone, this is the edge of capstone. And then I am done with my section in that manner. So once that is done, at least I'm confident what is going to happen. I can be able actually to even have my arrows of traffic just to show the direction of traffic at that point. And I can also do the same for this other side to show how traffic is going to maneuver into this area. Now, there is the other point. If you find that this can be accommodated in your section, there should be uniformity of design. And this is an obvious thing that it follows our natural human behavior. That if we go to this section and we see Y, or we see something like this, what we expect is when we go to another similar area or another similar section, that is sharing some similar characteristics, we expect the same thing. So this is why, for example, when you're designing your these intersections, it's important if we have decided that, and we can see that this one is being accommodated. Let me see. Let me see what is remaining of the medial section. It's 3 meters. So okay. 3 meters. It's actually almost 3.5 meters. So that can be able to accommodate a good ditch at this section. So if this is the design that we have adopted in this section, please note that even in the other sections, the drivers will be expecting that you have an acceleration and a deceleration lane. So this is very, very, very important for you to maintain the consistency of your design. And that is a principle. Actually, it's among the first principles of design, that if you need to ensure consistency of the design elements to make sure that the drivers don't get any surprise elements along your project road. Okay. Now, the next thing that you'll be doing is now we want to design the turning that we need to have. So what we're gonna do is the same thing that we did to this section. We want to extend our roadway at least some meters up there so that it can be able to accommodate the U-turn, and then we show a section that is above the U-turn. In this case, we can actually be able even to do an offset of, like, let's say even 50 meters up to that point. And therefore, what happens is I can be able to just extend my elements to this area. So I'm going to say extend, and I am done with that extension. So after extending, now we know this is the mark where our U section should be able to start from. It's important also to note that during this extension, we should have done it before, because now it has extended it as 3 lanes. And that is not the case. That is not what should happen. Because the deceleration lanes are not, they are not going all the way to this bit. So what I'm gonna do is, of course, use the trim mark, or rather break. I can be able to break this one at this point, and then I want to break also this one at this point. But then after that, I can be able to trim these other ones. I want to select those two. And then also, I want to select these, and I want to select these, and then I want to do to trim them. So I want to remove these, I want to remove this, and I want to remove this. So what is left of me is MA, and make sure that now I can be able to go back to the edge of traveled way, identify it here, and also get to identify it here. Then from there, I will also indicate my shoulders. I remember my shoulders were 1.5 meters. So I'm going to set this to 1.5, 1.5. And then MA to match my shoulders. You don't want to have any confusion at this point. So just do your work slowly. There is no gun on your head to rush. Now, after that, we are able now to say at this point, this is where we want to have our median. And this is now the normal road section. For us to do that, let me just do the usual U-turn that we did. I told you that for you to be able to do any design, you must first be able to access the existing site conditions and what is ideal for your area. So this is how a normal U-turn, considering the median that we have, the median of the section that we have, this is what we can be able to, this is what we can be able to achieve. The next thing would be to take measurements for the same. So you have the radius of this is actually 1.7. That is the radius. Remember, in this case, we are meaning that our vehicle is turning from the inner lane to the inner lane here. It's turning from the deceleration section into this acceleration section. And sometimes that may be difficult. And this is now the other limitation of when you have the two lanes very close here, the turning may be an issue for your design. That is always now the other challenge that you find. And especially if the median has become too narrow. If the median has become too narrow after adding your both other deceleration and acceleration lane, therefore it becomes difficult for you to get a sufficient distance to make the maneuver. And therefore, what this would force is, of course, vehicles not even actually being able to use the deceleration section here, but turning all the way into the inner lane. And that's why it's called the loon. It's an improvement of or a devised kind of a design element that is meant to utilize sections where you cannot be able to have a complete maneuver. So, but let's proceed and see whether this can be justified. So I'm going to offset. You remember we must have an offset of 0.5 for the path of our vehicle. Remember the vehicle is 2.5 meters wide. And when we do the 0.5, it means whatever will be left even in the edge of this traveled way, the vehicle will be able to move smoothly here. And then after that, we do another offset of, for example, let's say the 3.5 meters. Oh no, it should be for this one. And of course, yes, the 0.5 and the 0.5. So that is ideally forms the ideal path that we would see for a normal vehicle. And let's check whether that is also something that we can be able to look to work with. So I'm going to select a passenger car. Of course, that is always the first vehicle that you're designing. That's where you always start with. And you're going to start at this point and you come with it very, very, very nicely up to that area. And then you get to this point and you'll be able to make a turn. Sorry, let me get to do these. Okay, I think I did a mistake there. Let me add one extra vehicle right there. And then after that, we can be able to make a complete turn. And then after that, we can be able to add one extra vehicle right there. I can see someone is in the chat box. I know. Okay, so that's done. That's done. So what we need to do is adjust and see how this fits into our design. Um, uh, then you can be able to check it out. So that's it. You can turn this area. Uh, and now this is now the other challenge. You see now, the reason as to why having if you look at it, if I wanted my vehicles uh, to turn directly from the deceleration lane to the inner lane, it's something that is achievable. I can be able to achieve that. But me turning from the acceleration lane and having a deceleration lane and then going direct into another acceleration lane here within a very short median, it's impractical. It's impractical. It's impractical. So the size of the median here, as detailed in the AASHTO Green Book, determines the kind of arrangement that you're going to have here. So it is easy for a designer to assume that if I do a deceleration and deceleration here, it's going to work perfectly fine. But as you can see, it is almost impossible for this, even a minor passenger car, to get from this point, just like you've designed it, and get into this other area. And these are the things that you get, of course, with practical insights here. And you can be able to see it is not possible for us to achieve such a maneuver. The best maneuver we can be able to achieve at this point is to be able to have our small passenger car moving from the deceleration lane and getting into the inner lane. So therefore, this means our design, our proposal to provide this acceleration lane at this point is not viable for this section. It is not viable for this section. Therefore, it would be, and if, for example, we removed it, let me change this to some other layer. Let me just, for example, get to use this layer number 10 for my design. And let's say now we are assuming we don't want to have it. So it means that our vehicle would be turning from this point, and then it would be going all the way into where is the inner lane? All the way to the inner lane. So this means I can be able to remove this one. And in this case, if we go to annotate, I can check and see my radius is at 3 meters. It means also our median is becoming smaller and smaller for these sections. And that's why we're having 3 meters. You remember from the design vehicle manual, or from the manual that we saw, we need at least 3.8 meters. So you can see the median is just slightly it's slightly narrow for us to accommodate this one. Because if we were to do, check that out, if we were to achieve the 3.8 meters that is allowing a passenger car to turn, this is how this would look like. So our median would be a little bit bigger. So these are scenarios that requires you now to devise on how we can be able to do our design. So let's offset this by 0.5. Okay, not this one, sorry. We need to go back to where it should be. That is the first principle. That is the first principle. So we are going to the edge from the inner lane of this section to the inner lane of this other section. And then after that, we can be able to offset it by 0.5. And then offset it 3.5 first. Remember that is always the inner, the principle. And then, sorry, 0.5. That is always the principle. This is the first, you must first start with the first principles. So we are iterating with the first principle, and that is not possible. And then we do this second one to check and see what happens. And this is why If you go, for example, for registration, you're doing your designs for the registration of or as a professional engineer and or professional technical engineer, all of those things, exams, you design from the first principle. All your designs must be from the first principle and not improvements of what you think should be the case in that area. The first thing that must be done is your design must be fully as per the first principle. And then if you can be able to explain the first principles, then it means it's easier for you now to use your knowledge to devise other methods of application or to solve other problems. So this one could be like that. This could be like that. Not that area. That way. Let me just end it at that area, but I will tweak it. Um, so let me add these. And then I can be able to complete my maneuver in that manner. So you can see also, even if we go to the fast lane from the inner lane to the outer lane, it's becoming very difficult for the vehicle to make an intersection in this area. So we can see the impact that the size of our median plays when it comes to the U-turn design. There are scenarios where the median is too small. It cannot be able to accommodate a complete U-turn. It cannot. It cannot be able to complete it. And therefore, you would need to do some widening of the outer edge. Remember now, that is it, the outer edge for this roadway to be able to accommodate the complete turn of the vehicle, because that is the only option that is left for us here. It's practically very, 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 very impossible for us to do that. So it would require us widening the outer edge of the roadway, and then, of course, widening this section just a little bit, just the same way it was done. You remember the same principle that we used to widen this section so that we can be able to accommodate the turning maneuvers at that specific point. So that is it for me. I was not gonna do this section for you. So please go and do the section for yourself. It's a way to practice. You've already seen how we have done this other part. So go and replicate the same knowledge in this area. Make decisions. As an engineer, your point is to make decisions. And as I told you, make sure that what you are adhering to are the first principles of design. That is what you should be learning now. So how would you make sure this section will adhere to the first principles of design? How will you make sure that in your design that you're going to give to the client? And this is always the other problem. Don't think in terms of saving the client and soiling the profession. Don't think about saving the client and spoiling the profession. Because if you spoil the profession, it is your responsibility. It is your moral obligation to protect the profession and to be, an ethical engineer. That is always your principle. So if this is not fitting in here, so what do you do? What do you suggest? You can do the widening, and I want to see how you modify the section to fit in. You can see clearly the vehicle tracking, we have done it here. It's impossible to turn. So I want to see what can you be able to modify out of this area and ensure that your design is compliant with the first principles of design. What do you propose? Remember again, we were working for a client. This is a private developer who hired us to provide a solution for them. So please note, the solution that we are providing should not affect the existing traffic. It should not disrupt the traffic for us to fit in. And these are some of the causes of why this proposal would not be approved. But then, if you can be able to devise a way how you restructure and redesign this section to accommodate these turns and maneuvers for a safety, then your proposal will be accepted. And that is basically what your work is. And that's basically what you'll be doing for governments. That's what you'll be doing for clients. That's what you will be doing for companies and developers. Provide a solution. Provide a solution. So this is a task for you. This is a challenge for you. Tomorrow, I will be looking at what challenges, how did you get to solve this point? How did you get to solve? What proposals are you having for this area? Please, for those of us like Sam and I think it's Innocent who have been working on this project, make sure that you work so that we have at least something to look at tomorrow. Otherwise, we will proceed into now the production so that now we see how do we get to compile a proper book of drawings. That is the task that is left for us because we are already done with the design. So what we'll be doing next week and actually from tomorrow after you guys bring your proposals, we review them and finalize. From that point on going forward, we will be preparing a proper book of drawing that we can be able to submit to the client for approvals. So thank you very much. It's always an honor to see you guys. I'm wishing you a fantastic day. I don't want to spend your day here. I also have a lot of things that are pressuring me today that needs to be taken care of. So go out there and win. Please practice, stop watching. Thank you very much, and I'm wishing you a very, very fruitful day. The recording shall be provided, so please feel free to watch anytime. Have a blessed day, everyone. Thank you very much.